Right, we are now on question 4.3, and then the question says calculate the length of the tangent AB drawn from the point A to the circle with equation x minus 3 all squared plus y plus 1 all squared is equals to 10. All right, let us have a rough sketch to try to have a picture. Let's have our Cartesian plane, y-axis, x-axis. Then the center of our circle will be given by what? 3 and -1. We get our center here. Our center 3 and -1 from the equation. It will be roughly here, 3 and -1. And we are told that there is a point. The question says a tangent AB drawn from the point to the circle. Therefore, this point is a point outside the circle with the coordinates 6 and 4. So let's have that point maybe somewhere here, 6 and 4. The point A with the coordinates 6 and 4. So now this will just be the rough sketch of our circle X, and this is a point here. Then if the tangent is AB, therefore B will be the point of tangents. So B, if it's somewhere here, therefore AB will be what? Will be a tangent. Or someone else maybe can put B somewhere here. AB will still be what? Tangent. Remember, we know from Euclidean geometry that a tangent drawn from the same point outside the circle will be equal in length. So, but we are going to work with only one point. Let's work with what? With this B. So now we must find the length of what? AB. But now we have a center here. We have a center, and then let C represent the what? The center of the circle. Point C represent the center of a circle, and we know that BC will be our what? Our radius. If BC is a radius and AB is a tangent, then angle B will be what? 90 degrees, because we know that a radius and a tangent will be perpendicular at the point of contact. So now let's also join what? A and C. Let's join A and C. Then we can see that ABC is actually a what? A right angled triangle. Therefore, let's determine the length of AC. The length of AC will be given by using the distance formula, the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Then point A, let it be our x1, y1, and point C, our x2, y2. Therefore, AC is equals to x2, 3 minus x1, 6 all squared plus y2, -1 minus 4 y1 all squared. Then this will be equals to AC, the square root of 3 minus 6 all squared plus -1 minus 4 all squared. This gives us the square root of 34. Square root of 34. So now that we know the square root of 34 is equals to AC, then can we find now what CB? CB is our what? Our radius. The radius from the equation up here, from the equation, we have what? 10, which is what? A radius squared. Therefore, the radius will be the square root of 10. And then, since triangle ABC is a right-angled triangle, we can then what? Use the theorem of Pythagoras by saying the hypotenuse squared. Our hypotenuse is AC. AC squared will be equals to BC squared plus AB squared. Then this is Pythagoras theorem. Again, when we are using Euclidean geometry statements in analytical geometry, we have to give Euclidean geometry reasons. So what is AC? AC squared will be the square root of 34 squared is equals to BC squared will be square root of 10 squared plus AB squared. Then square root of 34 squared is 34 will be equals to root 10 squared is 10 plus AB squared. Then subtract 10 on both sides. 34 minus 10 is 24, which will be equals to AB squared. Therefore, AB squared will be equals to 24. Then AB will be equals to the square root of 24, of which rounded off to 2 decimal places, the square root of 24 will be equals to 4,90. 4,90 rounded to 2 decimal places.